Hi all, welcome to the lecture series on Aerospace Propulsion. Myself, Manideep Gupta, Assistant Professor, Department of Aeronautical Engineering from MLR Institute of Technology. Today, the topic which we are going to discuss is about the ignition of solid propellants, design of solid propellant and ignition of solid propellants. Coming to the overview of today's presentation, we will discuss about the design of solid propellant rocket. We will go through the ignition of solid propellant rocket. In that, we will also discuss about the igniters, pyrotechnic igniter and pyrogen igniter. Coming to the first one, design of solid propellant rocket. The previous class itself we have gone through the components. So this is here you can see the how the solid propellant rocket is designed. Okay, a solid propellant rocket will have one case. Okay, and in that case there will be one liner. After that, an insulation layer will be there. Then you will have a propellant grain. Next, you will have propellant grain here, and whatever the propellant grain here, you can see it will have some hollow section in the middle, which is nothing but acting as a combustion chamber. Okay, and here you can see the nozzle here, and also nozzle closure is placed when the propellant grain is submerged with the nozzle here. And to start the ignition process, we will have one igniter at the starting. Here, this is your igniter. Okay, this igniter will consist of easily burnable mixtures. Okay, so this is about the design of a solid rocket motor. Okay, propellant grain is having some insulation layer, and it is attached to the rocket motor case with the help of a liner, and there will be one igniter to start the burning, and it has attached to a nozzle to control the expansion of gases. But coming one point here we have to discuss is once the ignition process starts, it cannot be stopped in the middle for a solid propellant rocket motor. Okay, this is the one disadvantage and a main difference. One is a very important difference between the liquid propellant and solid propellant rocket motor. So next we will discuss how the ignition process happens in the solid rocket motor. Coming to the ignition of solid propellant rockets, first what happens? Transferring of heat energy. The main purpose of ignition is transferring of heat energy to the propellant surface by ignition. So we have to transfer the heat energy to the propellant surface so that the propellant surface get heated and the chemical reaction starts, heat will be generated, pressure develops in the combustion chamber, and the gases formed in the combustion chamber will rush to the low pressure region and form some momentum. So this is the total process happens. So how this ignition process happens in the solid propellant rocket motor? So the combustion of in the igniter, what we place is we place easily burnable mixtures such as potassium nitrate with charcoal powder and sulfur, etc. in the igniter. Even we call this mixture like a potassium nitrate with the charcoal, also called as black powder. This easily burnable mixture will start the ignition process immediately, and next to enhance the energy transfer. Okay, so the burner will start releasing energy. It will transfer to the solid propellant grain surface, right? To enhance the energy transfer to the propellant surface, we can also add metals such as boron, copper, also included in the burnable mixture of the igniter. Even ammonium perchlorate with polymer metals are also used. Also used in the burnable mixtures, that is in the igniter. And next, when the igniter starts burning, it is releasing gases will come, solid, liquid products also will come. So in that, if the solid and liquid products, then in the igniter has much better retention capacity to provide good contact and heating of the propellant. Whatever the solid and liquid substances, the products after burning the mixture in the igniter, that will have high heat retention capacity. It will hold high heat amount of energy. So when the solid and liquid substance comes from the igniter, contacts to the propellant grain, that will transfer energy to the propellant grain easily, and the propellant grain starts burning immediately. So we'll try to make the mixture such that it will release solid and liquid products from the igniter. Next, metal oxides. Even we add some metal oxides. Like iron, magnesium, copper, or lead with metals such as aluminum are also used in the igniter mixture, so that the heat concentration increases, and whatever the molten products that will transfer the heat energy immediately to the propellant grain. So whatever this mixture, like a mixture of this metal oxides with metals is called thermite. So one type of mixture is a black powder, that is potassium nitrate with the charcoal powder. And next, propellant, even we can use metals like boron and copper in the igniter mixture, and also we can, along with these metals, we can also add metal oxides to get molten materials, to get molten products which are very valuable for ignition process. Okay, either we can use thermite mixture or else we can use black powder, metals with metal oxides, also used in the igniters for immediate combustion and heat transfer to the propellant grain. So when the igniter starts releasing this solid, liquid and gases with a high heat, that will enter into the combustion chamber, or that means propellant grain surface. So how this energy transfer? So heat radiation, the heat can be transferred either by convection radiation, right? Heat radiation is partially absorbed and partially reflected from the surface of the propellant. And whatever the heating of the propellant, that leads to the release of volatile vapors of the fuel and oxidizer from the surface. So whenever the propellant grain surface exposed to the heating, it will release volatile vapors. Volatile vapors of fuel and oxidizer of the surface. So what happens? The energy, the temperature in the surroundings nearby the surface will start increasing because of the reaction process. So ultimately what happens? Pyrolysis of the propellant and like a photochemical decomposition of also occurs at the surface in-depth regions of the propellant. Even pyrolysis of the propellant also happens on the surface and near the layers which are near to the propellant grain surface also. Next, the heat also generated by chemical reactions. So whenever the sufficient amount of energy is available for starting the chemical reaction, then the chemicals like fuel and oxide will start react each other and produces energy. So the heat also generated by the chemical reaction at the surface and to a small level in the subsurface region also. Suppose if you take propellant grain like this, and if I assume this is a surface, so and layers, if I divide this total propellant grain into some layers, so the chemical reaction happens like much easily on the surface, and even it will, the small whatever the heat transferred to the sub layers, 1, 2, 3 sub layers, these layers will also start a small reaction process will start in the sub layers also. So ignition occurs when the net heat generated by the different reactions is able to lead steady state combustion. So ignition starts. So that means we start that ignition when the steady state combustion is going on. Then that is we can say that ignition is done completely. So ignition occurs when the net heat generated by the reactions will continue the process of combustion. Then we can say ignition is done perfectly, and the propellant grain will burn continuously and releases hot gases. So the igniter, while heating up a small region of the propellant surface and initiating combustion therein, also enhances the pressure in the port volume. So whenever the grain starts reacting and generating heat energy, because of that high heat energy will increase the pressure in the chamber. So the pressure in the port volume starts increasing. That means it will enhance. Next, the spread of the flame. The flame will spread from locally ignited zone, thereafter covers the entire port surface. Right? And next, the spread of the flame from the locally ignited area over the entire surface of the propellant is called flame spread. Next, the pressure continues to increase due to the mass added from locally ignited zone and from the zones which gets ignited during the flame spread till the steady state pressure occurs. So when the propellant grain initially when the propellant starts reacting, the pressure will start increasing. Okay, but this pressure will increase up to an extent where the pressure will get a steady state. The pressure will get the required pressure develops in the chamber till that the reaction starts, and after that continue a constant pressure will be maintained in the combustion chamber based upon the grain configuration. Even some grain configuration, the pressure increases continuously for a progressive burning, and in regressive burning the pressure decreases also. Based upon the requirement, the pressure in the steady state pressure, the pressure will be maintained in the combustion chamber of a propellant grain. So if you classify this process of ignition, okay, it is classified into three regions, right? One is port volume pressurization or local ignition, and next flame spread and chamber filling or equilibrium to attain the equilibrium pressure, right? The steps involved in the ignition process: port volume pressurization is the first step, flame will spread to the total propellant grain, and chamber filling to equilibrium pressure. The total combustion chamber will get equilibrium pressure, will go to a steady state pressure. So there is the third step of the ignition process. Here you can observe the diagram here. Here whatever the black region you can see here, this black region, this is the local ignition area. Okay, this is the local ignition area, and this will start spread to the all propellant grain surface, which is nothing but called the flame spread. After that, the pressure in the chamber increases. The same thing you can also observe here, the process. Okay, the process, these three stages of ignition can also be observed in this graph. Here on the y-axis you can see the pressure, and on the x-axis you can see the temperature. This A to B is the first step, local ignition and pressurization of the port volume. The pressure will increase to an extent. Next, flame spread is the second step, that is from B to C. Here you can observe the rise in the pressure from B to C, and the chamber filling, the total chamber will get steady state pressure. That is the third stage. Here that happens in the from C to D. From C to D, the pressure is increasing and almost maintaining a constant pressure. Okay, when we see the graph of action time and burn time, then there you can see this constant steady state pressure time also here. So the C to D is a chamber filling stage. So this is the process of ignition in a solid propellant rocket motor. Next, igniters, right? Igniters are the main thing to initiate the ignition, right? So let us discuss the igniters. Here, coming to the igniters, there are two types of igniters. One is a pyrotechnic igniter, one is pyrogen igniter. Okay, what actually happens? What is the difference? We'll see now. Okay, coming to the pyrotechnic igniter. The combustion of the igniter charge is initiated electrically. So in this igniter, whatever the combustion products, like what are the chemicals, that starts ignited with the help of electrical energy. So this electrical energy is supplied with the help of electrical resistance wire, like a nichrome wire, and this nichrome wire is also coated readily with the ignitable substance. So this nichrome wire is a good resistor, and it is coated with the easily ignitable substance. So whenever this nichrome wire powered with electricity, the resistance wire will get heated. Because of that heat, whatever the coating material about around the nichrome wire, that will start burn and it will start ignition. Whatever this nichrome wire with coated with a readily substance is called a skib. So this skib is enclosed in a small quantity of another ignitable substance. Okay, whatever the small electrical wire, right, that is again placed in another easily ignitable substance such as potassium nitrate. So when the current is passed through this resistance wire, the rapid combustion of the potassium nitrate initiates the burning of the pyrotechnic composition. Whatever the mixture, propellant mixture we place in the igniter, that is we are calling as pyrotechnic composition. So in order to, sometimes even what happens, we connect this nichrome wire to the electrical supply, right? Sometimes there will be some transfer of static electricity transfer in an accident. So to avoid that accidental transfer of electricity to the nichrome wire, what we do is electrostatic charges discharge and stray, to stop the stray electric currents. A threshold value of current is specified above which only the ignition takes place. Whatever the resistance, it will place some electric discharges. Will stop the accidental electric discharges by controlling the threshold value of a current. So if the current supplied crosses the threshold value, okay, then only the nichrome wire will the nichrome wire will get heated. So even though a small electric discharges will not start the ignition process. So that is one preventive measure we have to take in order to avoid the accidental starting of ignition process in the pyrotechnic igniter. Here you can see the diagram of the pyrotechnic igniter. Okay, here this is the pyrotechnic igniter here, and this is the propellant grain, solid propellant grain, and here you can see a rectangular box. This is the igniter here, and this igniter has a pyrotechnic composition. This igniter has pyrotechnic composition in it, and this pyrotechnic composition is placed with a nichrome wire. This is the nichrome wire, and it is powered with some DC or AC supply, so that whenever the supply goes to this nichrome wire, it will get heated, and this will start it will start burning the pyrotechnic composition in the igniter, and it will release hot gases. Whatever the hot gases released from the igniter, that will spread in the combustion chamber volume, and it will start burning the propellant grain surface. Pressure increases and the combustion starts and continues. Okay, so this is one type of igniter. Pyrotechnic igniter can be used if the propellant grain size is small. We can use for this type of igniters for a small rockets. But coming to a large rockets, okay, this ignition using pyrotechnic igniter is somewhat difficult. We cannot just initiate the total process of combustion in a less span of time. It is difficult to control the total ignition of the propellant grain with the help of pyrotechnic igniter. So for that, what we do is we go for pyrogen igniter. This is a next level igniter which is used for large rocket motors. Okay, when a solid rocket is very large, the amount of igniter charge required for the ignition will be more. So more propellant mixture, more pyrotechnic mixture is required. So in that case, what we do is controlled burning for a large amount of charge is difficult. So we substitute the small solid rocket for the igniter. What we place is in the place of igniter, we place a small rocket motor, small solid rocket motor, small solid rocket. Okay, in the igniter place for a large rocket. So whatever the plumes from the small rocket with a very thin wave initiates the combustion of a main rocket. So even the small rocket, we place pyrotechnic igniter in the small rocket. So ignition of the small rocket, which is the igniter now, is achieved by using a pyrotechnic igniter. Okay, even for the small rocket also we have to use pyrotechnic igniter. So pyrotechnic igniter is mandatory for solid rocket motor. Okay, the small rocket used for ignition is known as pyrogen igniter. Whatever the small rocket placed in as a igniter for a large rocket is nothing but called as pyrogen igniter. And here one problem comes when you use metal oxides or metals or the thermite mixture in the pyrogen igniter. What happens is it is noted that propellants with high metals contents should not be used for the pyrogen igniter. Why? Because whatever this metal and like condensed metals. Okay, whatever the condensed metals that will settle at the nozzle throat. Okay, whatever molten metals will settle at the nozzle throat and it will change the configuration. So that's why we should avoid using of high metal content propellants in the pyrogen igniter, because it will block the flow at the nozzle throat. There is one thing we have to be considered for large rockets. Here you can see the diagram of a pyrogen igniter. See, in the previous diagram we have gone through only a small rocket, a small igniter with a nichrome wires like this. Okay, here this is nothing but the small black one. This is the pyrotechnic igniter and this is the small rocket, and this way is the small rocket here. So this is nothing but the pyrogen igniter. Again we have one pyrotechnic igniter with a squib, right? So this is about the ignition process and the types of igniters in the solid propellant rocket motor. So coming to the summary, we have gone through the design of solid rocket motor, and we have gone through the process of ignition of solid rocket motors, and we discussed the types of igniters. One is a pyrotechnic igniter and pyrogen igniter. Thank you.